Hey guys, welcome to my channel. This video is on Pure 2 Exercise 9a questions 1 to 5, the differentiation chapter. So let's get started. Okay, the first question is differentiation by first principles, and it's asking for showing that f dash x is equal to this expression. Okay, so at first let's write the information down. It's f of x equals cos x, and then we need to write the formula of differentiating by first principles, which is f dash x equals limit of h approaches 0, f of x plus h minus f of x over h. Okay, now we write this again, and denominator remains the same, and here will be our function is cos, so it will be cos x plus h minus cos x. And for the next step, you need to be aware of here, because this is the addition formula, which you already learned in chapter 7, which is, because we have that also here, which is equal to cos A times cos B minus sine A times sine B. So we're going to apply the same principle here, which will be limit of h approaches 0 of h cos x cos h minus sine x sine h and minus cos x. And for the next step, we need to notice to the fact that we have a common factor here, which is cos x. So we can do factorization, which can be written in this form, cos h minus 1, because we took cos x as our factor, minus um, sine x times by sine h. And we can separate our expressions to tidy this up a bit. So it's going to be cos h minus 1 over cos x over h, and then minus sine x sine h over h. Okay, and here we need to consider the fact that the value of h is small and is approaching 0, and we will be able to use the small angle approximation as well. So here, at first, if we consider that, as h tends to 0, so cos h is also going to tend to 1. So here will be 1, and 1 minus 1 is 0. So this whole expression will be 0. And here, the thing we need to consider is using the small angle approximation. And by doing that, we will find that out, that sine of 0 in the small, so sine h will be h according to small approximation rule, because sine x equals 2x when x is small. And we can simplify this, and what remains is just minus sine x. So we prove the questions, and I just proved the whole question in one section, but it should have been in two different sections. Still, you get the idea, right? Okay, let's get to the next question. So differentiate these different functions. Okay, so at first I'm just going to show you something. So this diagram will be very helpful to you in terms of remembering the differentiation of trig functions. So let me just okay, now it's better. Okay, here is sine x, here is cos x minus sine x, and cos x minus sine x minus cos x, sorry. And what you need to remember is that when you're differentiating, it goes clockwise. So the only thing you need to do is just remembering this diagram. For example, sine x differentiates to cos x differentiates to minus sine x, and minus sine x differentiates to minus cos x, and minus cos x differentiates to sine x. That's all you need to remember for these types of differentiations, which are really useful to know that. Okay, so part A, dy with dx equals to minus 2 sine x, according to this diagram as a hint. B, dy by dx is equal to 2 divided by 2 because it's 2 times a half, and sine x differentiates to cos x, so it will be cos half x and cos half x. That's the answer for part B. And part C, dy by dx is equal to 8 cos 8x. And because remember, when here there is a number, it also will be multiplied here. So remember just this thing, because there are many students who forget this and they will lose the marks. And for part D, dy by dx is equal to 6 times 2 over 3, and here will be cos 2/3 x, which is equal to 4 cos 2/3 x. Okay, next question. Again, it's differentiation. F dash x is minus 2 sine x. B is f dash x is minus 5 sine x. C, f dash x is minus 2. Um, sorry, here should have been 5 over 6x. I was about to forget this as well. So for part C, the answer is it's plus. Sorry, it's messed up. Here is going to be minus 2 sine half x, and for D, f dash x equals minus 6 sine 2x. Okay, I was a bit confused because when I was halfway through doing part C, I corrected part B and I kind of forgot it. That here should have been negative. Yeah. And yeah, this is question 3. And we need to move to the next question. Feel free to pause the video and have a go at the other questions as well. Okay. So part A, dy by dx is 2 cos 2x minus 3 sine 3x. B, dy by dx is minus 8 sine, 4x, and here is plus 4 sine x, and here will be minus 14 sine 7x. And for part C, by dx is 2x minus 12 sine 3x. And for this part, what we need to do is at first separating and the denominator. So it's going to be 1 over x plus 2x sine 5x over x. And these two cancel each other out, the two x's I mean. And then what remains is going to be, I'm going to write the rest of that here. Y is equal to x to the power of minus 1 plus 2 sine 5x. And now it's going to be a simple differentiation. And yeah, plus 10 cos 5x. Okay. And finally, the last question is question 5, which is a bit different and maybe slightly interesting. A curve has equation y equals x minus sine 3x. Find the stationary points of the curve in the interval x is between 0 and pi. Okay. The first thing we need to remember is that the point, the gradient of the stationary point is equal to the 0. So what does it mean? It means that at first we need to differentiate this and put the answer equal to 0. So we will be able to solve an equation, and by getting values for x, we can plug them into this equation in order to get their y's as well. So they're going to be the coordinates of the stationary points of this curve. So let's do all of them. Okay, at first is writing dy by dx is equal to 0. So let's find dy by dx first, which is going to be 1. And here is is plus 3 cos 3x. And the next step is writing using this principle, which is going to be minus 1 is equal to, um, I think I made a mistake in differentiating this equation, because here is minus sine x and it should have been minus cos x. Yeah, it's not positive. Sorry. Yeah, and now um, it's going to be 1 is equal to 3 cos 3x. And next step is rearranging this equation. Cos 3x equals a third. And now you're going to solve this equation in the interval 3 times 0, 3x, 3 pi, and then divide all our answers by 3. Okay. So if we use our calculator for these questions, the values of 3x are going to equal to 1.23. Remember that your calculator is in radians. 1.23, because the calculus always works on radians, not degrees. And here is 1.23. Calculus in trigonometry, I meant that. Yeah, 1.23, and the next answer is going to be 5.75 and 7.51, and then divide them by 3. So the answers are going to be 0.41, 1.68, and 2.5. Okay, these are your x values, and the last step is just plugging each of these x values into the main equation in order to get the y values, so that you'll have your coordinates. So 0.4 for the first point, 1.68, and also 2.5. Okay, I'm just going to use my calculator for this question, so hopefully we will be able to get the final answer. Okay, so 0.4 minus sine 3 times 0.4 is minus 0.53, so minus 0.53, and also 1.68, 2.63, 2.63, and the last one 2.5, 1.56. Okay, so guys, if you enjoyed the video, please like and subscribe for more videos. See you later.